Joan Daemen, Professor of Symmetric Cryptography, Radboud University Nijmegen, Netherlands. BBVA Foundation Frontiers of Knowledge Awards in Information and Communication Technologies. What is the Rijndael algorithm, and what was your specific contribution to its creation?
Well, Rijndael is in fact an encryption method. An encryption method is to convert readable text, like a file or a Word document or a web page, into an unreadable format for someone who doesn't have certain information, and that information is the key. So you can actually convert something readable into something unreadable, and this can be made readable again. That's called decryption by using the same key. And Rijndael is a method to do that. And my contribution is that I had the initial idea of starting this project. Then I contacted my partner Vincent, my partner in crime with which I did that. And then we developed over the years a number of ciphers that would lead to the Rijndael algorithm, with which we won the AES contests.
Why did the Rijndael algorithm become the Advanced Encryption Standard, and how has it managed to keep that status to this day?
Yeah, so I told about the AES contest. So that was the American Institute of Standardization in the 1997-98. They wanted a successor for the then encryption standard DES, and that was heavily broken. And they decided to have a public competition where everybody could participate. And we participated with our proposal Rijndael. And after a few years of competition where all competitors were, people tried to break them, and we tried to break competitors and competitors tried to break us, and we had a lot of comparisons. Then NIST decided that Rijndael won the AES competition. So that's how Rijndael became the standard. It won the competition. And then after that, it just stayed unbroken. So it was never really broken in these 25 years that has passed, and it's not broken to this day. So we think it's very likely that it will never be broken.
Where is this algorithm used nowadays, and why is it important for the security of our digital society?
Well, it has proliferated quite a lot, so it's used all over the place. You can actually say that most CPUs, so most processing units in laptops, in tablets, in smartphones, but also in many smart devices like smart TVs or smart cars and so on, contains Rijndael hardware. So Rijndael software has been there for longer. Software is basically sequences of operations that you execute on a processor, but Rijndael is there in hardware. That means that there are dedicated instructions on a CPU, on a central processing unit, that do Rijndael. And this you can find in most devices, for instance, on a smartphone or a TV near you.
In an era where quantum computers are getting larger and more powerful, to what extent will it be necessary to update the encryption standard of our devices?
Yeah, there are actually two types of encryption. One is public key and the other is symmetric key. And Rijndael is in the symmetric key category. And there is actually, for the moment, no threat from quantum computers for symmetric crypto. The threat is at the public key crypto. And what we see there is that the current standards are being replaced by new standards, and we see a migration taking place to crypto that resists quantum computers, and that's called post-quantum crypto. And here at the university, there are also people actively working on that.